Hello, everyone. Today we're going to talk about facial expression recognition in remote learning conditions. Have you ever gotten to a situation where you want to get feedback from your participants, but you only have 5 seconds to do so? Remote learning makes it very hard for speakers and guests to interact and engage in nonverbal communication. But don't worry, our groups presents you a solution to this.
The methodology we followed for building our application first involved taking an image from a Zoom setting or any other video conference setting. Then, with the help of OpenCV, any faces in the video frame are detected and cropped down to a smaller size. These cropped faces are then passed through a convolutional neural network trained using the FER 2013 dataset. The output of our model in this application is in a prediction of the emotion of the cropped face. Here's an example of some of the faces contained in the FER 2013 dataset. Could you recognize the emotion? We trained our model to try and recognize 5 different expressions: happy, angry, surprise, fear, sad, disgust, and neutral.
When built the facial recognition model, we first tried to figure out the most accurate and simple CNN structures from past paper and GitHub, and then we shift to transfer learning and train our data based on a model weight that has been proved to work in other facial image problems, and finally get our best accuracy from ResNet, which gives us a test accuracy about 72%. So here we use ROC curve and confusion matrix to evaluate our model. Our model actually did a pretty good job in detecting happy and surprised faces, but slightly poorly job on detecting fear, sadness, and neutral. One thing to keep in mind, this is actually not an easy task. So remind yourself with the previous exercise. Isn't it hard to recognize the difference between sad, fear, and neutral, even for us, like human body? Actually, according to research, on average, human can only achieve 80% of the accuracy in this facial recognition dataset, which is just slightly improvement from our model accuracy.
All right, now let's move to a fun game. I'm going to display a Zoom participant page with 49 participants. How fast could you recognize these emotions? We'll have 5 seconds for this task. So, are you ready? Let's go. How do you feel about this task? Are you confident about your guess? Generally, when we are doing it, we find it a bit challenging to complete this task, and we're not very confident about our guess. On the other hand, our application takes around only 5 seconds to scan frame and generate predictions for a 7x7 Zoom gallery view. It scales up pretty easily from a single participant to multiple participants and outperforms human in terms of time efficiency. In addition, when we only take a glance at the participant page, our focus is limited. For example, if we only land our focus in the middle of this page, we could potentially ignore the participants in the peripheral vision, which is proven to be weak for humans to distinguish details. Taking a closer look at these participants, if we land our focus on the center, we could potentially miss these confused faces on the edges. Our application does not have this limitation. It takes all the participants into account and recognizes their emotions effectively and efficiently.
And here's the conclusion and discussion section. Our overall model accuracy is 0.72. The algorithm generally beats humans in speed and detects faces at the edge. However, humans still might perform better in some cases involving subjective judgments and subtle difference. To further improve the model accuracy and make our application more practical, more data is needed, and we consider collapsing emotions into common ones appearing under Zoom settings. We also consider adding distraction algorithm that only take faces of participants who turn their cameras on and look at the camera. As you can see here on the right, it first detects whether there's a face present, and then it asks whether the participant is paying attention, and finally, it starts to classify what's the facial expression of the participant. One final word of warning. This model is trained on human faces. It might not be applicable to animal faces, for example, your cat. Thanks for watching.